Well, I see two fractions here, so the first thing I'm thinking is LCD. So let's get the LCD here. The LCD is x plus 3, x plus 2, and of course we cannot use negative 3 and negative 2 because that'll give us division by zeros. Now, if this were an equation, which it is not, but if this were this equation right here, if it was 4 over x plus 3 minus 3 over x plus 2 equals 0, we would take that LCD and we would write it next to every original term, right? We would write it here, here, and here. That is, we're multiplying both sides by the LCD. But this is not an equation. Here's the problem. We cannot do that because, you know, when we multiply both sides of an inequality by a number, if that number is positive, the symbol stays the same direction. But what if this was negative? Then that symbol would change direction. And our problem is that we don't know if this is positive or negative, right? It depends on the value of x. And we don't know what x is. So we cannot just multiply both sides by the LCD as we did in the equation. So let's get rid of that because we don't want to fall into that trap. So I'm going to combine these two fractions as, what are we going to have here? I want everything over the LCD, which is x plus 3, x plus 2, and then we'll have the 4. Now, what did we do here? I changed the denominator. Right, here's the original denominator. Here's the new one. So you can see the original is being multiplied by x plus 2. So to keep this balanced, I have to multiply the top by x plus 2. And then I got the minus 3, but what do we need to adjust? We need to adjust that. Here's the original denominator. Here's the new one. What did we do? You can see the original right here. We multiplied it by x plus 3. So if you multiply the bottom by x plus 3, to keep this thing balanced, we need to multiply the top by x plus 3. And this is all greater than 0. Let's multiply through. We'll get 4x plus 8 minus 3x minus 9 all over that x plus 3, x plus 2 greater than 0. And then 4x minus 3x, that's x. 8 minus 9 is minus 1 over x plus 3, x plus 2, and that whole thing is positive. All right, so we're at a form now that we can deal with. I got one single term with a numerator and denominator. I'm going to get my critical values and draw the number line and test some numbers. So it took us some upfront work. If you remember problem 41, it was already given to us as a fraction. This time, we had to get it. All right, so what are the critical values here? Critical values. What's going to make the top 0? 1. What's going to make the bottom 0? Negative 3 and negative 2. And x cannot equal negative 3, negative 2 because those numbers give us division by 0. Now the 1 is okay. You can have 0 in the top, but just no zeros in the bottom. So here's our three critical values. Let's draw a number line and mark them on the number line. So here's the number line. I'll draw it real big. X. Now I've got three values here. I've got negative 3. Now I'm going to have to put an open circle at negative 3 because we can't have negative 3. And then an open circle at negative 2 because x cannot be negative 2. But I can put a closed circle here at 1. Now let's pick a test point in this interval here. Pick any number less than negative 3, like maybe negative 4. So if you put that negative 4 down here, okay, what have you got? Well, if you put negative 4 in the top, negative 4 minus 1 is negative. So we would have a negative here in the top. What about the bottom? Well, if you put that negative 4 here and here, right, negative 4 plus 3 is negative. Negative 4 plus 2 is negative, so you get two negatives down there. So this would be negative, negative. You multiply and divide with those three negatives, you end up with a negative. So what we're saying is that if you pick any number in this interval, substitute it in here, you're going to get a negative over a positive, which is negative. So this whole thing would be negative. And negative greater than 0, that's false. No solutions in that interval. Let's move on to this interval. Pick a number here like maybe negative 2.5. So if I pick 2.5 and put 2.5 right here, I'll get negative 2.5 minus 1 is negative. So that would be negative. And what about in the denominator? If you put negative 2.5 here, negative 2.5 plus 3 is positive, right? Negative 2.5 and then you add 3 puts you up to positive. But then negative 2.5 here, negative 2.5, if you up 2, you're still negative. So it's going to be positive, negative in that denominator. And when you divide, multiplying that out, you end up with a positive, right? So what we're saying is that if you pick any number in this interval, substitute it down in here, you will get a negative over positive times negative, negative. So you end up with negative over negative, which is positive. So then you're saying a positive number greater than 0. And that's true. So we have solutions there. Let's go on to this interval. If you pick any number in here, like maybe 0, and if you now put 0, follow it along here, back over here, put 0 in here, 0 on the top, 0 minus 1 is negative. So I would get a negative here. And then put 0 in the denominator. What do you get with, okay, so put that 0 down here. 0 plus 3, 0 plus 2. 0 plus 3 is positive. 0 plus 2 is positive. So you end up with positive, positive. So all in all, you get a negative divided by positive. Right, positive, positive is positive. Negative over positive is all negative. So we are saying that if you pick any number in this interval, substitute it back here, you'll get a negative number over a positive number, which is negative, and then you're saying that negative is greater than 0, which of course is false. So no solutions there. And now finally, let's just check this last interval. So if we pick any number bigger than 1, say 2, and put that 2 back in all these three factors here. If I put 2 here, 2 minus 1 is positive, 2 plus 3 is positive, 2 plus 2 is positive. The whole thing looks like this. Positive, 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 and you compute that out, you get a positive. And we're saying that if you pick any number in this interval here, put that number right back in here and substitute, you will get a positive over a positive, which is a positive number. Compute, you get a positive number. And a positive number is greater than 0, so that's true. Now I can see what the solutions are and are not. So the solutions are in the two intervals marked with T's. So they're here. I'll draw them in red here. And way out here. I'm going to write my solution. Now if I just bring these things straight down, if I just bring this straight down, so I have this, I'd have negative 3 and negative 2. Well, let me change the color on that. So I would have negative 3 and negative 2, and then where are the x's? The x's are right inside here. So the x's are right between those, so I'll write my x there, and then what do you have for signs? An arrow and an arrow with they're open, right? So they're not, they're strict inequalities. So we could be there, or we could be way over here in this interval, which are all the x's that are greater than 2, right? All the x's are greater than or equal to 2, right? Because equal to, because that's a closed circle there. So there we have it. There's our solutions. Well, we're not quite done. I see I've made a mistake here. Do you see this? If I bring everything straight down like this, I was looking over here at that 2, not the 1. So I need to make a change here. So what I'm going to do is say that where are those x's that make this thing work? They are to the right of 1, not 2. Right, that should work better.